There's a fact to consider that makes a big point about COVID 19. Here's the fact, and hang with me because this will seem unrelated, but it's the same. It's very related. The more ice cream we sell in the United States, the more women will be raped. That is a true fact. The more ice cream we sell in the United States, the more women will be raped. Of course, it's correlative, not causative. And if I were, and the reason, of course, is that when people are out for the summer, people drink more. They're more vulnerable. They're traveling. They're more vulnerable than if they're locked at home or in school in the cold weather behind a locked door. So the more ice cream you sell, the more women get raped is a very true statement. If I were dishonest and I didn't like ice cream, or if I were just uninformed and you told me that fact and I did not know that ice cream was unrelated to rape, I might become angry at everyone who sells ice cream. And I might start making ice cream illegal. It happens often, sometimes intentionally and dishonestly, sometimes unintentionally, just by correlating instead of looking for the cause. So, in the effort to find a better way or another way to think about what's happening with the pandemic, I thought, what can you correlate and what's caused and what isn't? I can't find something that's correlative across every state except for what we're getting to. But let's say that you correlate the number of tests with the death rate. That's what I'm looking at. How many people are dying? That hasn't been done. But even if it did, it wouldn't mean that numbers of tests are helping save lives. It could be the ice cream thing with rape thing. But I can't find a number that correlates, as in when you have more of it, there's more death. Death rate or death per million, not absolute numbers. Obviously, when you have more numbers of people, there is likely to be more people dying. But if there's a higher number of people, an incidence rate, number of people per million dying, if that goes up relative to something else called an independent variable. So, for example, if you said the more people who travel and get drunk at the same time, the more likely people are to be raped, that's probably a true thing because of obvious reasons. But if you said ice cream, we would know that's not the same. All right, so what do we know relates to infection? We know that the more people are together, or physically bunched together, the more likely they are to transmit, hence social distancing. So I thought, let's look for that rate, look for that graph, and see what it is, and see if we can use that as a way to predict who's doing well, who isn't, what we might change. So you can actually look at this chart. Here it is. Here's the states, all 50 states, and you can look and see, and I added in, just for your information, New York City and Switzerland. You can see the number of square miles and the population. For example, Alabama has square miles of 52,000 square miles with around 5 million people over a population density of 94 people per square mile. Where with Alaska, you have 665,000 square miles and only about that many people, so around one person per square mile. Where with New York, actually with New York City, look at this, with New York City, it's in the stratosphere. You have 8 million people with only 468 square miles. Think about that for a second. 8 million people with 468 square miles versus Alabama, 5 million people with 52,000 square miles. 52,000 square miles and about half the number of people as New York City in only 468 square miles. So that makes sense that would cause an increased incidence of infection no matter what you did with ventilators or masks or testing. Doesn't mean you don't do things to flatten the curve, but the question is, does something, if there's an incidence rate associated with population density, instead of thinking flattening the curve, can you drop the number of people dying per million? It would be the same thing, sort of, but not really. So let's think about that, and let's first come out, what's the graph? If this is the population density, Hawaii has 220 people per square mile, as in 6,000 square miles and 1 million people. Okay, so here's the population density for every state. Nevada has 29 people per square mile. New Jersey has 1,200 people per square mile. It's a big difference, right? 10 times as many people. The state of New York isn't very high, but the city of New York is in the stratosphere, right? 27,000 people per square mile. So now let's look at deaths per million and do the regression analysis and see. So here's the deaths per million for every state and Switzerland and New York City. So here's the regression analysis, and you'll find that when you click this. So if you do that regression analysis and try to find a linear relationship, so in this chart, here's the number of people per square mile for every state. I left out New York City and Switzerland. I just wanted those. And here is the deaths per million as of May the 26th, 2020. And this calculation would change with time, but it would be similar. So if you graph that out, graph this out, and you do regression analysis, you get this line. So all 50 states are on there. They're just bunched together, but you can see at a low population density, so if you're only 200 people per square mile, then nobody's over about 500 deaths per million people. But by the time you go up, it goes up, and down here there's a very linear relationship. So in Alaska, there's very few deaths. So Alaska, there's one person per square mile, only 14 deaths per million people. So where does this become useful? By doing a regression analysis, you get a calculation. So you should be able to predict from this what the deaths should be per million people based on population density. And it does correlate. You can calculate that, and the correlation coefficient is the way you measure it, and it's 0.68. It's thought to be a very strong correlation if it's 0.7 or more, and you can see this is almost 0.7, so it's a moderate to strong correlation. What about these outliers? What is this? This is in the state of New York. So many more people died per million than what was predicted based on population density. I'm guessing that's because you have so many people in the city of New York crammed together. When I say crammed, I don't mean unpleasantly crammed. It's a beautiful place to live, but I mean from a pandemic standpoint, it's a lot of people in a small space. This is the state of Florida, which actually has more people on the average per square mile, but they have a very low death rate or death incidence of numbers of people dying per. There it is. So if you look at Florida, only 105 people dying per million, even though there's almost 1,000 people per square mile. Why is that? I don't know. Is it a policy? Is it a policy difference? Is it because they have more? Well, this is Florida. Is it a policy difference? They have more people per square mile than the state of New York, or is it because they're just more spread out than in New York? Well, or is it because there's more sunshine? I don't know. But the point is, there is an independent variable that correlates with the number of people who die in a state, strongly correlates, and if a state is above or below that line, it's at least worth thinking about what the reason might be. I don't know another number that correlates. Number of ventilators, does that correlate? Number of people wearing masks. People in Florida are already partying in the beach, so it doesn't correlate with numbers of people or percentages of people inside versus outside. I don't know what the answer is, but it's worth using this or considering using this as a guide to what policies might be working based on whether it's above or below this line. One other thing worth thinking about is just the idea that the reason people are opening up now in June is incidents will go up, and the reason I'm talking about numbers of people dying per million, the incidents will go up just by testing more people. It just will happen. If someone says to the mortality rate and they haven't tested thousands of people that are asymptomatic, they either don't understand the math or they're lying to you, because you have to check everybody, well and unwell. There's a doctor's office down the street from me where everybody and the doctors, all the nurses tested positive, but none of them got sick. So, but if you want to something there's very little fudge factor in, is you just count dead bodies. And if you count the people who have died, that's not going to change much even if you test more people. So if you just met, and everyone who dies gets checked. So if you count the people that have died every day in the United States and tested positive for COVID-19, whether that caused it or not, it's still a good way to get an estimate. If you count the number of people who died, it's following that bell curve, and there's a very good chance that it's going to go back down close to baseline somewhere around the end of May, 1st of June. So hopefully that, or end of May, middle of June, I should say. And it's never going to be zero, but it's going to go close to zero by the middle of June.